Today we are going to solve this question. Find the analytic function of f of z u plus vi, given that the real part and the imaginary part are what? Both given. So solution. So since the imaginary part and the real part are given, so what we should do, since we know that fz is equals to u plus iv. So this is equation number 1. So this is equation number 1. So what we should do is to multiply the whole of this equation by I. So if we multiply the whole of this equation by I, so we have z is equals to u plus iv. So we multiply by I, it is equals to iv z is equals to iu minus. So I multiplied by I is I squared, and I squared is equals to -1. So we have V. So we have this equation, and we say equation number 2. This is equation number 2. So second we add the equation, this equation and this equation. If we add fz is equals to u plus vi plus ifz is equals to iv minus v. If we add, we are going to have z plus if z is equals to u, this is u, plus I u minus v plus iv. So we correct like terms, or we factorize here. If we factorize z, fz, we have 1 plus I is equals to, we correct those part without I. So this one and this one. So we have u minus v plus iu plus iv. So we have z open bracket 1 plus I is equals to u minus v plus, we factorize I. So we have u plus v. So we can let this part to be capital letter F, this part to be capital letter U plus I, this part to be capital letter V. So after reaching this step, we can find the derivative now of z with respect to u. So u over x plus I dv over x. Again, we can find the derivative of z with respect now to y. So it will be du over dy, we say minus I dv over dy. So after deriving these equations, we can now go ahead to find our analytic function. Analytic what? Function. So since we have this equation, so our first step, we should find the derivative of a partial derivative of with respect to x. So we have our partial derivative of u with respect to x is equals to, when we differentiate this one with respect to x, we have 1. When we differentiate this one with respect to x, we have e to power x open bracket cos y minus siny y. This one, there is no x, so it is just, we are not interested in this part. So since we know that the partial derivative v with respect to x is equals to fill 1 x comma y, and let x is equals to z and y is equals to what? 0. So if we let x is equals to z and y is equals to 0, so we have du dx is equals to fill 1 z comma 0. So where there is x in this partial derivative, we are going to replace z, and where there is y in this partial derivative, we are going to replace what? 0. So since we know that our fill 1z comma 0 is equals to, and our partial derivative is 1 plus ex cos y minus sin y. So z comma 0 is equals to 1 plus e to power z cos 0 minus sin 0. So you have z is equals to 1 plus e to power z, open bracket, here it is 1 and here it is 0, is equals to 1 plus e to power z. So this is our partial derivative with respect to x. Now our second step is to find the partial derivative with respect to y. So our u partial derivative with respect to y, so we differentiate this one, keeping y the constant, so it is negative 1, plus we differentiate here with respect to what? To y, so it will be e to power x, open bracket, negative sin y minus cos y. And since we know that the v u minus v over dy is equals to 2 x comma y, so which is equals to this, our partial derivative, which is negative 1 plus e to power x, open bracket, negative sin y minus cos y, and our x is equals to z and our y is equals to what? 0. So we have the u minus v over dy, which is equals to, open bracket, z comma 0 is equals to negative 1 plus e to power z. So when we replace 0 here, it will be automatically 0. When we replace 0 here, it will be automatically negative 1. So we have fill 2 z comma 0 is equals to negative 1 minus e to power z. So since we have these partial derivatives and we are told to find the what? The analytic function. And we are told to find the analytic what? Function. And we know that the derivative of f is equals to 1 z comma 0 minus I, the derivative of 2 z comma 0. So we're going to replace, and we let our 1 to be our derivative with respect to x, which is this one. Our derivative with respect to what? To x, which is this one. So we're going to replace here, which is equals to our derivative with respect to x, which is this one, is 1 plus e to power z minus I, and our derivative with respect to y, our derivative with respect to y, which is this one of -1 minus e to power z, plus what? C. Plus our what? Our c. So we have fz. So after finding this now, we can also, after finding this, since we know that f prime is equals to 1 plus e to power z, we can multiply I, negative I times 1, it will be positive I. Again, negative I times, it will be positive I e to power z plus c. Plus c. So we can differentiate, or before we differentiate, before we integrate, we have z is equals to, we can correct like terms. We have I e to power z plus c, 1 plus I plus c. So we can factorize, which is z. We have 1 plus I, again plus c, I plus 1. This is I plus c. So we can integrate both sides. With respect to z. So we have the integral. So we can factorize, which is I, 1 plus I, the integral of e to power z, plus here, even here we can say 1 plus I. So we can integrate dy plus c dz. So if we integrate here, we have a big z, which is 1 plus I. If we integrate this one, automatically z to power e to power z plus, if we integrate this one, we have 1 plus I. Since there is 1, if we integrate, it is z plus what? C. Since we know that our big Z is equals to small z plus 1 plus I. From our beginning, as I introduced the lesson, I said that this part is equals to 1 plus I. So here we're going to replace 1 plus I. This one, we're going to replace this one with 1 plus I is equals to 1 plus I, open bracket, which is e to power z plus 1 plus I, z plus c. So we divide throughout plus 1 I, 1 plus I, 1 plus I. This is at 1 plus I. So we have e to power z is equals to e to power z plus z plus z. Here you can say d. And this is our analytic function. Thank you for watching.